Alright, so today we're going to be working on activity 2.1.7, problem number 4. I'm going to walk you through this so we can determine both the external and the internal forces and reaction forces on this truss, and we can work the math here in order to find out what all of these are. So the first step, of course, is to determine static whether this is statically indeterminate or not. So, and if you recall, that formula is 2J equals M plus R in forces. And on this, if you remember, we've got a roller here and we've got a pin here. So we're going to have, in terms of reaction forces, we've got two reaction forces on a pin, a reaction force that in the X and a reaction force in the Y. And we have one reaction force on a roller. So we'll have three reaction forces. Number of members is 1, 2, 3. So we've got 3 members. And we've got 1, 2, 3 joints. So 2 times 3 is 6. Does that equal 6? So yes, 6 does indeed equal 6. So it is statically determinate. We can go ahead and work this out. So our next step here is I'm going to go ahead and redraw my truss into a little simpler style. I'm just going to use some straight lines here as I go. So we've got point A, we got point B, we've got point C. So, and I'll go ahead and label these. We've got A, this is B, this is C. On C we got this 50-pound force. Here on A, we've got the force of A at X, in the X, the force at A in the X. And on B, we've got a force of B in the X, and we got a force of B in the Y. Now, if we start out right away, we notice something here. Both of our forces in the X are both moving this way and pushing that there. So obviously that can't be the case, because if we've got two forces, both of them are going this way, there's nothing to counter that force, so this would cause this to move. So we need one of these forces is going to be on the opposite direction. And we've got the same thing going on here. So we've got negative 50 pounds here, and we're making an assumption here the force of By is in that case too, going down. So again, if this is the case, there would be nothing to stop and keep this truss from moving. So something's not quite right, and we'll figure that out here as we go. So first off, we will solve for the sum of the forces in the X. So, and as we look, we got sum of the forces in the X equals 0. So, and the forces that we have in the X are F of AX plus F of Bx. Let's go ahead and do our algebra now. We've got two possible scenarios here. We have negative F of AX equals F of Bx, or we have negative F of Bx equals F of AX. So that doesn't really help us. We're not quite sure just yet where we're at on that. Let's go ahead and solve the forces in the Y. Sum of the forces in the Y equals 0. And the sum here, we've got negative, because we're going down, forces of By minus 50 pounds, negative 50 pounds. That's the forces at C. That's an applied force. These are reaction forces. So going ahead with our algebra, F of By equals minus 50 pounds. Alright, now, because we have a minus 50 pounds here, that's telling us that this is the opposite. So it should be going the opposite direction, and we should be going up. So let's replace this. This is going to be going up to counter that force there in the Y at F of B. And now we can go ahead with our moments. So the sum of moments. We got to decide here which point, where do we want to go through with our moment? Well, the most logical place, we got two forces here on B, so we only have one force on C and one force on A. So let's take the one with two forces on it. So we're going to take the moment about B. Sum of the moments equals 0. Again, a moment, if you recall, a moment is force times distance. So, well, here we've got the force of By, but we got 0 distance, so there's no moment there. And we got the force of Bx, but there's 0 distance, so there's no moment there. However, we do have a moment about A, and that's going to be plus the moment about C. So let's go ahead and go through the moment about A. Now we're going to replace moment about A with the force about A times the distance about A, plus the force about C times the distance about C. Alright, so our force about A, we don't really know that yet, so let's just go ahead, force of AX, that's still open. And in this case, we see that we're here, the force is going this way, we're 3 feet away from it, and our force is pointed this way, so we're going to be going counterclockwise. So force of A times 3 feet, and we'll just make a note that that is counterclockwise, plus here we have the force at C, and we do know what that is. The force at C is 50 pounds, and it is pushing about A. Again, we're 3 feet here is our distance. So, and this is going to be clockwise. So now if we recall something, counterclockwise means that we're positive. So this is going to be positive f of AX times 3 feet. Counterclockwise is negative, minus, I'm going to go ahead and do my math here, 150 feet. All of that equals 0. So again, f of AX equals times 3 feet will end up equaling 150 pound-feet. I almost forgot we got pounds here with our forces. So, because this was 50 pounds up here, so 50 pounds times 3 feet gives me 150 pound-feet. So, f of AX equals 150 pound-feet divided by 3 feet. My feet cancel out, and I'm left with f of AX equals 50 pounds. So now I can replace this. We know that this is 50 pounds. And it's positive, which means that it is going that direction. Now, so, as I look at back here, now I know this is positive 50 pounds. F of Bx is negative 50 pounds, which lets me know my force at Bx is actually going the opposite direction here, and the force of Bx should be a negative 50 pounds. So, and I've just now used what I found here with my moment. So I've got my force of By, so this is equal to 50 pounds. And my force of AX and my force of BX are all there. This is the first part of the truss. So we will come back and I will go over the second part of the truss, because now we've found the reaction forces. Our next point we'll find the forces, the internal forces of truss member AB, truss member AC, and truss member BC. So we will come back and find out either the tensile or the compression in each of those members here in the next video.